Good morning. Elevate is a very exciting time of the year for myself as well as the Appeon team because we get to share with you how we're moving PowerBuilder forward and get your valuable feedback. But this year is especially exciting for us because we will share with you various customer success stories who have taken the first version of PowerBuilder 2019 and successfully moved to an API architecture with C# programming language and the .NET framework. Some of the customers you will hear from today are FoundationSoft, America's leading cost-based accounting software for the construction industry. You will hear from Pemex, Mexican state-owned petroleum company, as well as Eventum, Europe's ticketing giant. You will also hear from Appeon's team members, Govinda, our technical evangelist, and Julie, the PowerBuilder product manager, about how we're taking those C# and API features from PowerBuilder 2019 and revising them, enhancing them in R2. We have especially made a lot of advancements in the productivity of helping you move to C# and an API architecture. We have also enhanced the PowerScript client, which we hope will be your primary choice as your UI technology for your API C# architecture. So without further ado, I'd like to kick off this morning's first keynote presentation, which will focus on the next generation of DataWindows that Appeon is introducing in PowerBuilder 2019 R2. The next generation of DataWindows, standard, open, and extensible architecture. Boy, that's a mouthful. Well, let me tell you that all of us at Appeon love PowerBuilder and we love DataWindows. And we know all of you as PowerBuilder developers love DataWindow technology. But in moving forward in an API architecture world, as well as with C# programming language, we think it's necessary to bring forward a new generation of DataWindow that has an architecture that fits this sort of cloud API development, as well as following best practices of the .NET framework and C# programming. Before we talk about what we're doing with DataWindows, let's first talk about APIs and why they're important. You can see here how business systems architecture have evolved over each decade, starting from the 70s with the mainframe, a monolithic business app, and then SAP leading sort of the IT awakening stage with ERP systems or enterprise-wide applications. And then PowerBuilder coming in the 90s and bringing those departmental apps, right, getting a much smaller unit of scale. And then in the 2000s, with the popularity of internet and software as a service and HTML, you start getting even smaller chunks, sometimes not even entire applications, but doing a particular service for you. And then now we're in the decade of APIs, and there's a lot of people leading the space. In the consumer section, we have Uber and Slack and so on. But we will be moving to even more granular, which is microservices. Think of that as just a smaller API. And the digital native decade is going to be most likely led by Amazon and Alibaba. Now, so if we take a look at the trend that's happening, the unit of apps or business logic is becoming smaller and smaller. We're unleashing the business logic from being trapped in a big system into granular building blocks that you can assemble and reassemble as you see fit. That's where things are going. Now, why is this important? Well, I read a few different various reports that have mentioned there's as much as $590 billion being spent a year on integration. That's just to make these silos of apps and their business logic talk to each other and work together. Now, besides cost savings, another very important point about APIs is being able to run faster than your competition. And in Silicon Valley, we frequently use the term "don't get Ubered." What does that mean? Well, Uber has been able to outrun, out innovate the competition. Why? Because they don't build everything themselves. They're actually this conglomerate of a bunch of APIs. And a few examples of what they're using is, for example, Google to do the mapping in the Uber app, Twilio to send text messages, SendGrid to send emails, Braintree APIs to process your transactions. So really, it's not just about cost savings, but also allowing your company to remain competitive and not get wiped out or Ubered. But let's talk about two of those API companies I just mentioned, SendGrid and Twilio. In fact, just this year, SendGrid got acquired by Twilio. But if we take a look at these businesses, they're not traditional SaaS vendors. What they've done is they've taken a particular business process and API enabled that and offering this API as a service to their customers. So as I mentioned, SendGrid, they're helping you provide APIs for sending email, and Twilio is helping provide APIs for sending text messages. Let's see how these companies have evolved. In 2015, SendGrid had a $2 million market cap or $200 million valuation. In just 4 years' time, they got acquired for $3 billion. That's massive growth. Now let's take a look at Twilio. Twilio in 2015 had a market cap of 500 million. And in just 4 years' time, their company has grown in value to $14.5 billion. And they were able to just gobble up SendGrid like it was something small. But what I'm trying to make the point is that besides saving money on integration, besides staying competitive, embracing APIs can enable your companies to engage in new business models, go after new business opportunities, and actually grow your business. It's not just about staying alive, it's about growing. And APIs are at the heart of that. All right, so hopefully I've convinced you that APIs are very important. We all know data windows are wonderful, but are we really going to be powering our APIs with data windows? After all, it's pretty well-known fact that DataWindow.net from Sybase was a huge failure. Just for the hell of it, I went to the Visual Studio Marketplace and I typed DataWindow.net, and the trial version is still up. It had 1,824 clicks, and ouch, 1-star review. Okay, well, no, we at Appian are not crazy. We learn from the past and don't make the same mistakes. And in this case, this was Sybase's mistake, which we sort of see coming, but that's a whole nother story. But the point is, I think it's important to take a look at why DataWindow.net failed. What is Appian doing differently this time with the next generation of data windows that it's not going to be a repeat of the past mistakes? Well, as you all know, DataWindow.net was end of life by version 2.5. It really didn't last long, and very few people were successful with it. Why is that? Well, first thing is it was unmanaged code. Ouch, that's a big no-no with the .NET framework and how that works. Secondly, it was designer dependent. Yes, you could use DataWindow.net with Visual Studio or some other .NET IDE, but you still had to use the data window designer that Sybase provided. Ouch again. And then it was Windows only. Now, that may not be such a big deal for the hardcore .NET fans, but we also have quite a few Java customers. And one of their biggest issues with .NET in the past was that it only ran on Windows. They want to run their systems securely on Linux or other operating systems. There was no separation of concerns. That's probably one of the biggest issues that caused all sorts of problems. From what we can see, Sybase basically took the data window from PowerScript exactly as it was, without re-architecting it, just simply ported it over to .NET without thinking how things are done in .NET and how people develop .NET applications. So its architecture was way off, creating all sorts of maintenance issues, not interoperating and integrating well with your business logic, and so on. And it was very slow. Why? Well, it was a port of something that was designed for the desktop, not for server-based applications. And further reinforcing the fact that it was a port and not a redesign or re-architect. It was single-threaded. Really? I mean, I can see that working for client server, for desktop apps, what people develop with PowerScript, but for .NET web applications and APIs, really, you're going to run single thread? That's no way going to succeed. And frankly, I'm not sure why this product was even released if it wasn't going to have a correct architecture to give it a good chance. So let's take a look at what Appeon is doing different, why we call this the next generation of data windows, how its architecture is standard, open, and extensible. Well, first of all, the implementation is completely from the ground up. It's not a port of anything from what we had before in PowerScript or C++. This is pure managed code written in C#. It's compatible not only with the .NET framework, but the new .NET Core framework. Now, the .NET Core is really important because it's open source, it's cross OS, yes, you could run on Linux, for example, and the .NET Core is really well suited for deploying to the cloud compared to the traditional .NET framework. In fact, starting from .NET Core 5.0, it is our understanding that Microsoft is going to completely phase out .NET, and there will only be one .NET framework, the .NET Core, which they will probably just rename to .NET 5.0. Now, another major change in the .NET DataStore of PowerBuilder 2019 R2 is that it is cross-ID. There is no SRD file or data window data object file that creates a dependency on the data window designer. Now, you could use the data window designer to create this, but we don't lock you down or limit you. You could even use a text editor to edit the model. And yes, it is model-oriented. These days, that's the architecture you want for your data access objects. So all of the important stuff that is typically in the data window data object, we have put in those as class attributes inside of the model of the .NET DataStore. And it supports multi-type implicit transactions. I'll talk more about that, but basically an implicit transaction is an automatic transaction rather than you having to hand code the transaction management. And the .NET DataStore supports multi-types. I'll be covering that, as well as type-safe data operations. Now, the .NET DataStore starting from R2 supports a generic API flavor, and because of that, it makes it inherit from an iList and readily integrate with other .NET libraries or .NET code that may not be using the .NET DataStore. So it can natively move data back and forth. And of course, it's multi-threading. We are targeting APIs and cloud, and you have to be multi-threaded. We've also put a big effort on performance. That was a huge focus in our design, and we've been able to deliver typically 2 to 5 times faster performance, even with a single user. Trying to do the multiple user testing is just not going to work because a lot of times it would crash. But even with a single user, we're able to deliver 2 to 5 times faster performance typically. All right, so these are the changes we're making, and we believe this new data window is ripe for an API world and should help make you more productive when you're developing APIs in C# or any other .NET language for that matter. So let's take a look at its architecture in detail. I talked about some characteristics and features of the solution, but the key point to take away from this complicated slide is that its architecture is layered and pluggable. Okay, so we have built the .NET DataStore on top of the Apache 2.0 open source Snap Objects framework. Okay, now the Snap Objects framework is a .NET and .NET Core ORM, and it provides a lot of functionality that we felt trying to use Entity Framework or some other ORM framework for .NET was not going to deliver the performance and the productivity that we were after. So the .NET DataStore is built on top of the Snap Objects framework. Now, what the Snap Objects framework does is, first of all, it takes care of your database provider layer. So, You have the various drivers that your database vendor will provide you, for example, SQL Server, Oracle, or Postgres. And then what the Snap Objects framework does is in this particular layer, the database provider layer, it's taking care of adjusting for the specifics of a particular database implementation. So there's a module for SQL Server in that layer, there's a module for Oracle, and so on. And the importance of that architecture is that way the data services layer doesn't care. It's SQL Server, Oracle, or so on. The database provider layer is taking care of that. And the data service layer just generically is taking care of data access, model binding, SQL generation, and transaction management. Now, of course, when generating SQL, it's going to be calling into the module at the database provider layer, which will then inform the SQL generator any specifics, for example, for SQL Server or Oracle or Postgres. Now, if we go one step up in the layer, we get to what the .NET DataStore provides, and it's providing a lot of productivity on top of the Snap Objects framework, especially if you're looking to migrate existing Power Builder business logic to APIs in C#. You're going to get a lot of productivity by using the .NET DataStore. And what that DataStore layer is doing at the core services is providing some of the key things that we know and love about DataWindows. So for example, the buffer management, change tracking, data grouping, and so on. And then on top of that, we have a pluggable services layer that allows us to add additional enhancements or more advanced features on top of the core functionality that DataWindows should be providing. So for example, one new feature for R2 is the ability to support data import-export templates in XML format that historically you might have been using in existing DataWindows. And some of the things we're thinking about doing for the future is, for example, an HTML5 render. And of course, the .NET DataStore can be referenced through either a generic ABI, where you would instantiate it as iDataStore model, or a non-generic API where you just instantiate it as iDataStore. So both API flavors are supported on top of this architecture. So let's talk a little more about this non-generic versus generic API. The non-generic API is going to give you almost the same set of functionality as the PowerScript data store. And it's practically no learning curve for Power BI developers because it's not inheriting from an iList, and the way you write it is very, very similar to how you typically code PowerScript to reference the data store. And it's great for automatic C# conversion. So for example, a new feature of R2 is the PowerScript migrator, which we'll be talking more about that in another keynote presentation this morning. But the PowerScript migrator helps to automatically migrate your PowerScript business logic to C#. And in doing such automatic migration, we use the non-generic API flavor so that we can increase the percentage of automatic conversion. Now, the generic way of writing it, which would be something you'd want to do if you're not doing an automatic migration of existing code, but rather developing from scratch, is going to give you the same functionality as the iDataStore, but in a standard .NET flavor. So you're not giving up functionality by using the generic API. Now, the advantage it's going to have over the non-generic, the biggest advantage is basically it's inherited from an iList, so it makes it very easy to integrate with existing .NET libraries. Now, that's not to say the non-generic iDataStore API approach of coding cannot integrate. It can. You would just have to do some additional codings. It doesn't inherently integrate because it's not inheriting from an iList. You'll have to write some code to do that transfer of the data. It's also going to open it up for leveraging more .NET features because there's certain things that in .NET requires you to use a generic API in order to do that. So it's possible in the future the generic API flavor will support more functionalities. It also makes coding more concise and clean. So for example, like if you mistype the model name, it's going to catch that. Versus in the non-generic approach, your model name is a string. And so it's not type safe. If you mistype that, you're not going to catch that error until runtime. Now let's take a look at multi-type implicit transactions. As I mentioned, the .NET DataStore is built on top of the open source SnapObjects framework. And that framework is providing this very powerful transaction management capability. This is something that ORM frameworks like Entity Framework do not do. Now, what you're seeing here is one single line of code. You're not sitting there hand coding the transaction management. All we're doing is using SnapObjects' track functions to register all the things that we want to be included in this automatic transaction. So for example, I have a first data store, and then I have some embedded SQL, and then I have a second data store. And I want all of these things to be included in transaction. So you can see we can have multiple data stores and multiple types of things, not just data stores, but also an embedded SQL. We could even include, for example, C# code using the track actions option. And so what this is saying is only if data store 1 is successful and the embedded SQL is successful and the data store 2 is successful, then okay, commit the changes, otherwise roll back. Now, the new architecture that you've been seeing has a number of benefits, and I just wanted to briefly summarize that. First of all, you're getting a physical separation of the data, the templates, and the UI of your application. That's very important for maintainability and a number of other reasons. Also, this architecture being layered and pluggable allows Appeon, the way we've designed it, to load and unload as needed. So we don't load the entire framework into memory. As a particular service is needed, it gets loaded into memory, and that offers not only saving memory, but also better performance. It also allows us to extend the functionality of not just the framework, but also you yourself as developers who are coding. It allows us to extend features and not introduce regressions. Generally speaking, if we're adding something new, any issues should be isolated only to that new feature and should not affect any of the existing services or existing functionality that you're using. And of course, that bug isolation also helps to improve our productivity and your productivity in debugging any problems, for example, with the new features. As well as much easier to maintain when you have a really well-architected, cleanly separated. That's one of the reasons why Appeon is able to take the .NET DataStore and advance it so quickly between revisions, as well as testability. So now I'm going to turn it over to Govinda, who's going to demonstrate the new .NET DataStore.
Thank you, Armeen. Okay, so let's take a quick look into the new features of the next release. So if we go and look into here, you'll notice that we have no longer the SRD files, and that is because we are no longer depending on these files anymore. So if I double click on this model right here, it's actually a data store. You'll notice that the attributes have been placed as class attributes right here, and they come from the SRD file itself. So in here we have the data window, the data window style, the table. We also have the data window select. Notice right here how we have the columns placeholder. Well, this is because if I were to modify any one of the columns from here, adding or deleting or renaming them or whatever, I don't have to retype all the SQL query again. This is done automatically for me right in here. So let's continue with looking to the data window sort, data window column, SQL default value, for example, the get date right here, data window compute, and well, we got everything from the SRD file placed as class attributes into the data store itself. So as I can recall, we actually have import export templates as well from the data windows, and these are in XML format. So in this data window, we actually have 3 export templates right in here. So these export templates have automatically been imported for me into C#, and they actually are XML. So this being standard, you can actually modify it, maintain it, or do whatever you might need with it in this or any other IDE you might need. So let's take a quick look into Visual Studio 2019, for example. And right here, you'll notice, let's just give it a second for this to load. Okay, so in here, I have my data store. I can actually modify it and maintain it in here as well. Here's my template as well, XML. Okay, so getting back into what Armeen was mentioning about that there are two different types of ways of managing the web API. One of them is a PV standard. The other one is a more generic C# way. Let's take a look into that. So here we have the iDataStore, and the traditional Power Builder way is we actually declare a data store, pass in the data object and the data context, then retrieve it and return the data store. But if I wanted to do a more generic way of managing the web API, and if I wanted to incorporate this with any other standard C# class or object or web API, then I can actually return an iList if I wished. So in this case, I'm actually declaring the data store, but I'm telling it that this is going to be an iList of the type the department. And this is done automatically for me because you'll see here, if we take a closer look at this, you'll notice that the iDataStore is actually inheriting an iList. So this is the way we can make this more generic and standard.